So in this section, we're going to be talking about acidity and basicity. So first, starting off, we have to define acids and bases. So there are multiple different definitions of acids and bases in organic chemistry, and you must be able to distinguish them. So there are 3 different definitions that we cover in Gen Chem: Arrhenius, Lewis, and BronstedLowry. But for the orgo section, we're just going to be focusing on Lewis acids and BronstedLowry acids and bases, okay? So I like to start with the BronstedLowry acid and base definition, because to me it's really the thing that has kind of been told to me over and over. So a BronstedLowry acid is a molecule that donates a proton. Okay, and a proton is just a hydrogen molecule without its electron. And just as a refresher, hydrogen is actually made up of a proton and a single electron. So there's no neutrons in it, okay? So if I get rid of the electron, then literally I just have a proton, and that's why the hydrogen atom without its electron, we just call it a proton, okay? So, and a BronstedLowry base is a molecule that accepts a proton. Okay, so let's look at an example of that real quick. So here we have water, and water is using its electrons, one of its lone pairs, to grab a proton here, okay, and form a bond. And the 2 electrons in this bond, so one of these electrons belongs to oxygen, that's this one, and the other one, this one, belongs to hydrogen. But remember, we're going to grab just the proton. We're not going to take the electron. So both of these electrons, oxygen's electron and hydrogen's electron, are going to go on to the oxygen atom. Okay, and what this is going to give us is here, let's zoom in here. Here, oxygen only has 1 lone pair. Okay, but when these 2 electrons in the bond go on to the oxygen, it will get, let's look over at this molecule, it will get a second lone pair. Okay, now we started off with 2 hydrogens here, but one of them was taken away by the water. So not only do we have this compound, but we also have a hydronium molecule floating around somewhere with 3 hydrogens and a positive charge. Okay, so this molecule, let's call this molecule A, and let's call this water molecule B. All right, so molecule A donated its proton. So it could be defined as a BronstedLowry acid. Molecule B, the water molecule, accepted the proton. It kind of stole the proton, but that's fine. It's just a choice of words. Accepted the proton. And so it can be classified as a BronstedLowry base. Okay? Now, let's look at the other definition, Lewis acids and Lewis bases. Now, I used to always forget which one was which. I knew they had to do with electrons, but I never could remember who gained electrons, who donated electrons, okay? So I'm going to show you something. First, let me define it. So a Lewis acid is a molecule that accepts electrons. And a Lewis base is a molecule that donates electrons. Okay, now For someone who always struggled with remembering which one was which, how did I remember it? Well, one day I suddenly realized that my Bronsted-Lowry acid and base definition, when I focused on who was donating and accepting a proton, that's how I would use those definitions for Bronsted-Lowry. But if I used the same molecules and instead focused on the electrons, I could immediately identify which one would be a Lewis acid and which would be the Lewis base. Because all Bronsted-Lowry acids can also be defined as Lewis acids, and all Bronsted-Lowry bases can be defined as Lewis bases. So let's look at what I mean. Here earlier when we looked at this picture, we were focusing on who donated a proton, who accepted a proton, right? And I realized very easily, because I have those definitions memorized, that this molecule was the acid and this molecule was the base, right? Just by looking at who donated and who accepted a proton. But instead, let me not focus on the protons, let me focus on the electrons. So notice this water molecule that's grabbing the proton, in order for it to grab that proton, it had to use its electrons to go grab it, okay? In other words, it had to take its lone pair and donate it to the proton to grab a proton, okay? And that follows the definition of a Lewis base, a molecule that donates electrons. Now let's look at this acid here. Earlier we said this was an acid because it donated its proton, but let me not look at the proton, let's look at the electrons in this bond here. Notice that the oxygen right now is bonded to a hydrogen, so it's sharing those electrons. But when the water molecule grabs the proton, where do these electrons go? Well, they go on to the oxygen, in which case oxygen takes full ownership of both of those electrons. So in essence, that oxygen has accepted fully the ownership of those electrons, okay? So, if I can remember the definitions of a Bronsted-Lowry acid and base with a focus on protons, if I just change what I'm focusing on, I can remember, oh yes, a base, in order to grab a proton, a base must donate electrons. And therefore, when you're looking at an acid who donates its protons, what happens to the electrons in that bond? Well, they go on to one of the atoms, which means the acid must accept its electrons, okay? So not all, really, and we've talked about this in the general chemistry section, but Bronsted-Lowry acids can be defined as Lewis acids, kind of like an umbrella system, right? So Lewis definition can be applied to a lot of different reactions. Bronsted and Lowry is kind of a smaller scope within Lewis acids, okay? That's not too important. Other than that, you can just memorize the definitions. But I thought it was very useful, if I knew one set of definitions, to just apply that knowledge in a different way to help me remember the Lewis definitions. So here's an example where I have a water molecule donating its electrons to the carbocation. So there's no protons involved in this whatsoever. Because there's no protons involved, I can't use my Bronsted-Lowry acid and base definition. But I have my Lewis acid and base definition, and those follow the electron movements. So the molecule that donates electrons is the acid. No, wait, nope, I lied. It's the base. Okay, so this is a Lewis base. And the molecule And the molecule that accepts electrons, which in this case is the carbocation, is the Lewis acid. So this is the accepts the electrons. And you can see it accepts the electrons from the base. Okay? So this bottom reaction, really you can only use the Lewis acid and base definitions to label who's the acid and who's the base. Whereas the top one, I could label them as Bronsted-Lowry acid and bases or Lewis acid and bases.